Alright, now let's do factor by grouping. Factor by grouping is fun. You do it when you have something bigger than squared. So if you'll notice in our first problem, number 1, under the factor by grouping section, the highest exponent is actually a 3. That gets a little scary, so we are going to group it. Now count the terms. We have 1, 2, 3, 4 terms. So I'm going to cut this problem in half. We're going to do karate. Hi-ya! Cut it right in half, right down the middle. So now I have 2 terms and 2 terms. So we're going to ignore the second half of the problem, just look at the first half. What is the greatest common factor on the first half? Well, 5 and 25, I can pull a 5 out of both of those. So that's what I'm going to do. I'm going to pull out a 5. Now let's look at the v's. I have v cubed and v squared. What can we pull out of both of those? V squared. Now I have to write down what's left. 25 divided by 5 is 5. V cubed divided by v squared is v. Now this one gets interesting. 5 divided by 5 is 1. V squared divided by v is 1. Most people like to put a 0 there. That is not correct. The answer is 1. You still have to put a 1. Now behind the line where you chopped, write down the sign. Then you'll always get the sign right. Now we have a 30 and a 6. What can we pull out of both of those? 6. What's left? 30 divided by 6 is 5. So I have 5. I still have my v. Can't forget that. Now I have a plus 1. Now notice what both of them have. Both of them have this wonderful 5v plus 1. That means that our grouping worked because they should match. We're going to write down what they both have first. Then our second binomial will be the stuff that's left over on the outside. Notice you have to include the sign with it. So that would be 5v squared plus 6. Now 5v squared plus 6, then we look at our quadratic. Can we factor that? In this case, no, you can't. Because there is nothing that will multiply to give me 6 and add to give me a 5 in there. So this would be our answer. Factor by grouping, cut it in half. Let's look at number 4. Same thing. How many terms do I have? 1, 2, 3, 4. Highest power is a 3. Cut it in half. Karate chop right down the middle. First 2. What's the highest number we can pull out of 28 and 16? I'm thinking that's a 4. Now, variables. Y cubed and y squared. I can pull out a y squared. What's left? 28 divided by 4 gives me 7. I had 3 y's. I took 2 away. Now I have 1 left. 16 divided by 4 gives me 4. So I need to add 4. I had 2 y's, took 2 away, so there's none left. I do not write it down. Behind the line, write down the sign. Notice it's a negative this time. That's going to make a difference. Now let's look at this. 21 and 12. What can we pull out of both 21 and 12? 3. Okay? So now negative 21 divided by negative 3 gives me a positive 7. We did not pull the y out, so we have to write it down. Negative 12 divided by negative 3 gives me positive 4. And yes, both of them match. We want to make sure both of them match, otherwise our factoring is not going to work. So we write down what they both match, 7y plus 4. Now we write down what's left on the outside. 4y squared minus 3. 4y squared minus 3. Again, the 4y squared minus 3 is not factorable. So we keep it as it is and box our answer. Let's do one more problem that's simple like this, and then we'll do one of the harder ones that has 6 terms. Okay? So here, 4 terms, cut it in half. Draw the line down the middle where we cut it. 24 and 15. That one's a little bit more challenging. I think the GCF is going to be 3. Because 24 can be divided by 3, 15 can be divided by 3. Now how many p's can we pull out? P squared. Okay, 24 divided by 3 is 8. I had 3 p's, I took 2 away. I'm left with 1. 15 divided by 3 is 5. I had 2 p's, took 2 away. I don't have any left. Behind the line, write down the sign. There's my negative. Now 56 and 35. Your first instinct is to say 5, but 56 is not divisible by 5. So what could both go into both of them? If you're not sure, you know you should end up with an 8. So how many times will 56 go into 8? 7 times. So let's pull out a 7 so that we have an 8p there. That way it matches. Now what's 35 divided by negative 7? Negative 35, negative 7, positive 5. Ta-da! Our wonderful little binomials match. That makes everybody happy. I have 8p plus 5, and then 3p squared minus 7. Where did we get the 3p squared minus 7? The stuff on the outside. The stuff on the outside always gives me the second binomial. Alright, now, let's go ahead and do one that's a really huge monster problem. Now notice how many terms we have in this problem. 1, 2, 3, 4, 5, 6. Notice there's an even number, so instead of cutting it down the middle, we are going to group it in pairs. So it's like karate twice. We're going to cut it in 2 places. We're still going to look for the GCF in each pair. So in the first 2, what's the GCF? Negative 4, and then how many x's can we pull out? X to the 4th. Okay? Now when you pull out the negative 4, you're left with a 1, and then an x. Because it had 5, took 4 away, I'm left with 1. This matches negative 4x to the 4th, negative 4x to the 4th, so you know you're going to get a 1. Here's the catch. It is a positive 1, because a negative divided by a negative is a positive. Behind the line, write down the sign. What can we pull out of the second 2? GCF? Well, there's no coefficients, so we can't pull anything out there. But notice they both are x's. So what's the highest number of x's we can pull out? X squared. Okay? When I pull out the x squared, I'm left with an x, and look at that. A plus 1. X squared divided by x squared is 1. Behind the line, write down the sign again. Minus. X minus 1. I can't pull anything out of there, so I'm just going to put a 1. So I'm going to divide each one of these terms by negative 1. So negative x divided by negative 1 is positive x. Negative 1 divided by negative 1 is positive 1. Now notice, all 3 binomials match. X plus 1, x plus 1, x plus 1. It should work out that way. If I have an even number, we can do this. Okay, so I get my x plus 1. Now what's left over? In this case, we have 3 things left over. All 3 things left over. So I have negative 4x to the 4th plus x squared minus 1. This gives me my complete answer because we're not going to factor the trinomial to the 4th power at this point.